Who can tell me what's a median? When I'm talking about triangles, what's a median?
Sir, can I?
Go ahead.
Yes, sir. So a median is the line which is drawn from a vertex to the midpoint of the base.
Good. Anyone with any other answers? Anyone with a different take? Go ahead.
I didn't understand the question at all.
My question is, what's a median? What do you mean by median?
The midpoint of a triangle.
Okay.
The line that divides the triangle into two halves.
Okay. Anyone with any other takes? Bhavya came close. Unmana fairly close, not really close. So let's understand what median is. What Unmana was telling, she went to bisector. We'll come to that also. Something that's dividing the entire triangle in half. So what was the meaning that we have over here? It says a line segment that joins a vertex. Guys, what's a vertex? The 3 points of the triangle, 3 ends of a triangle to the midpoint of the opposite side. So if I have a triangle, all right. So what are the vertices A, B, and C? Now what is he saying? It should start from the vertex. There should be a line which is dividing the opposite side of the triangle into 2 equal parts. Median. Remember when we were discussing data handling and statistics, I said that median comes from the word med, which means middle. I also told you about the etymology of this.
Yes.
So middle is, when something's in the middle, it's exactly in between, right? So if I draw lines from the vertices to the opposite sides of the triangle, it says it has to divide the opposite sides into 2 equal parts. Such a line segment. Why is it called a line segment? What's the difference between a line and a line segment? Remember, we discussed this in detail. A line segment has 2 specific definite endpoints. A line does not. Right? You remember? Yes. So that's the reason he says it's a line segment, because it is from this point to this point. Let me name it D. Let me name this E. Let me name this F. That is what he has also explained in this diagram, basically. It starts from a vertex, goes to the opposite and opposite side, divides it exactly into 2 equal parts. This is what a median means. Now, there is something important over here. There are certain properties or certain things you have to understand. If I have drawn a triangle, okay, we already have a triangle drawn over here. Let's take this. What are the 3 medians, guys? LS, right? RN,
yes, sir.
MT, right? It's something that we can see over here, right? Now these are the 3 medians. Now guys, remember when we were discussing lines and angles, there was a topic where we said when 2 or more lines intersect at a point, they are said to be concurrent. You remember?
Yes.
So
Yes.
these 3 medians are intersecting at a point called G, right? Now this is called the centroid.
Centroid.
Yes. And it is usually denoted by the letter G. That is the reason we are specific with it. All right. Now, logically, if you think, in a triangle, when I'm drawing medians, so how many medians do we have? A triangle will have 3 medians, right? 3 medians can be drawn. You guys agree with me?
Yes.
Now, we also know that these 3 medians meet at a common point. What is the common point? It is a point of concurrence. What is this point named G? What is it called? It is called a centroid. Beautiful. Now, if I think logically, the centroid of a triangle always lies inside the triangle. Can I say that? Irrespective of what kind of a triangle I have. This is an acute angle triangle. For example, let me take a right angle triangle. Okay. Now, say this is dividing this into 2 equal parts. This is dividing this into 2 equal parts. And there is another line, this, which is dividing this into 2 equal parts. This is again the centroid G. You guys agree with me? I took a right. One second. I took a right angle triangle and I took an acute. Similarly, if I take an obtuse angle and draw three medians, the centroid will again lie inside the triangle. Yes, Bhavya, tell me what your doubt is.
Sir, can we draw more than 3 medians in a triangle?
Okay, go back to the meaning of median, a line segment that joins a vertex of a triangle to the midpoint of the other side. How many vertices are there in a triangle?
3.
So how many lines can you draw from the vertex?
3.
Does that answer your question?
Yes, sir.
Yeah, okay. So now, I took the example in an acute angle triangle, I wrote it in a right angle triangle. For an obtuse angle triangle, I want you guys to do it and see in a median, or still, even in an acute angle triangle, even in an obtuse angle triangle, it lies in the center, denoted by G. Now, there is another important point over here that I want to stress upon. If I have time, I will explain how this has come. There's a proof, but I already have certain proofs that I've planned in mind to explain to you guys in today's session. So let me see if I find time for this one. The median, okay. Now you see the centroid G. The property or the theorem says that the centroid of a triangle divides the median in the ratio of 2:1. What does this mean? LS was the median, you guys agree with me? G was the centroid, and it says it divides it in the ratio of 2:1. That means LG is to GS is equal to 2:1. Similarly, MG is to GT equal to 2:1. Analogously, NG into GR is also in the ratio of 2:1. That is 2:1, 2:1, 2:1. Are you guys clear with this?
Yes.
Are you guys clear with the median, how and why the median always lies inside a triangle? We proved it by putting it down, and this very important theorem that the centroid divides the median in the ratio of 2:1. Let me see if I find time at the end of this session to prove this, or we can do it in the next class. Don't worry about it, because I already have certain proofs I want to discuss. Are we clear with this? So if I say that I have an equilateral triangle, what's an equilateral triangle? All the three sides are same, all the three angles are also same, right? So if I draw medians, what is going to happen? All the medians are going to be of the equal length. You agree with me? Medians in an equilateral triangle are of equal lengths. You guys agree with me? How or why has this happened? Because the three sides of an equilateral triangle are same, and even the three angles of the triangle are same, right? Are you guys following?
Yes, sir, but I have a doubt.
Yeah, go ahead.
Sir, we said that the common point of all the medians is the centroid, right?
Point of intersection, yes.
Actually, how do we, in what basis do we draw the median?
Okay. So, say I have a triangle. Now, I was just taking the sides. Now, if I say this is 4 centimeters, this is 6 centimeters, and this is 8 centimeters. We have the three vertices, A and C. Now, what would be the midpoint of BC, Priscilla? Something exactly in between. So, what would it divide it into? 4 centimeters, 4 centimeters, you agree with me? Now, what did we do for a median? We drew a line segment from the opposite vertex to the side that is opposite to the vertex. So what happens? These two became equal, 4 centimeters, 4 centimeters. Similarly from B, it became 3 centimeters, 3 centimeters. Similarly from C, it became 2 centimeters and 2 centimeters. That is how we arrived at the midpoints. Look at the meaning over here. From the opposite vertex. Now this is how we got the center. Are you clear with this? I was just taking line segments. I said sides AB, BC and AC. You can simply put in numerical values and figure it out. Are we clear with this, guys? Is the concept of median
Yes,
clear?
sir, thank you.
Yes, sir.
Any doubts?
No.
Have you guys understood why the centroid always lies inside? We drew it and we understood it. Instead of looking at really long proofs, we just drew it, imagined, and figured it out.